Okay, somebody asked me about the office hours. Office hours, that's important. So let me just write it down over here. My office hour. So also, I would like to talk once more detail about the labs in just a moment. So my office hour, in case you haven't written that down, it would be 1:30 to 3:30, Monday, Tuesday, and Thursday. Okay? So if you really cannot make it for my office hour, that's okay. Just drop me an email. Okay? Just make appointments. So if you really got trouble with the course contents, labs, or anything, just let me know. Just get in touch. Okay? Okay, so I would like to talk about one more detail which may be a little bit confusing. Maybe you learned about that back in the first year, but I would like to talk about it again, which is about how you can do number division in Java. It's quite a tricky issue. Okay, so you can try the example I'm going to write on the notes on Eclipse, but just to save time, I'm just going to mention a few points before I move on to the course contents. Okay? Okay, first of all, let me just tell you what the principle is. If you want to do number division in Java, so number division in Java. So the principle is very easy. So usually you have box divided by box. Okay? Let's say this is box number 1, this is box number 2. So here is the rule. If both box number 1 and box number 2 are integers, if they are both integers, the result will give you the quotients. Otherwise, if any of the box, if either box 1 or box 2 or both, if any one of them is actually happens to be not integer, meaning double or float, otherwise, it will be result with precision. Which means it might be 3.4, 6.9, etc. Okay? So that's the principle, very easy. All you gotta judge is if both sides are integers. If not both sides are integers, then the result must have some precision with the fractional part. Okay, let me illustrate it to you. Okay, so let's say first example here, I'm gonna write, let me just add another page over here. Okay, first one. I'm going to say print rather than system.out_println just to save my writing. If I say print, let's say 8 divided by 2. That's easy, just 4. Okay? If I say print 8.0 divided by 2, what would that be? 4.0. Okay, very good. Okay, you can see even though we are really doing the same division, but for number 1 here, both boxes are integers, so you only get the quotients, just 4. Okay, in this case, you will just get the mathematical division, give you more precision. Okay, let's do another one. If I get print, let's say 9 divided by 2, what would that be? 4, quotient. Okay. If I say print and then 9 divided by 2.0, 4.5. Okay, brilliant, very good. Okay, so far so good. Let me just use some variables to make things a little bit more interesting. Okay, let me say I got, let's say integer here, integer I, and which is 9. Integer j, which is 2. Okay, 2 integers. Okay. Now after this, okay, I'm going to write to here. if I say print, let's do the simple one, I divided by j, what's that? 4, okay? Both are integers. Now, how can I make the result? I want to keep I and j. I want to make the result 4.5. Somehow I want to change from int to double, right? And that's something you learned about back in first year. It's called casting, right? So what you can do is, you can say print, you can cast. However, I'm going to show you two versions over here. Double I divided by j over here, and print. And for this one, I'm going to emphasize really the point. I'm going to add an extra pair of parentheses over here in different color, and then double I divided by j. Let's call this option number 1, option number 2. Okay, option number 1, what would that be? I heard 4.5. Okay, anything else? 4. First of all, it has to be about double number since we got double involved, right? 4.0, why 4.0?
You're dividing I through j and then you're changing the 4.
Right, exactly. So now, okay, I'll explain that in just a moment. What about the second one? 4.5, okay. So now we gotta understand why, okay? So somehow you have to really understand, oh, sorry, I forgot one parenthesis here, okay? You really have to understand what double parentheses really, a pair of parentheses really mean in Java. It's just in mathematics. Whenever you put parentheses around, that means you want to force the order of evaluation. Like if you say 2 plus 3 multiplied by 4, you know that implicitly we're going to do 3 multiplied by 4 and then plus 2. If you want to force the order of evaluation, you have to put parentheses around. The same idea, okay? So now, let's talk about the first one. So what the first one will do is going to do I divided by j first. And I divided by j is just integer 4. And then you will cast from 4 into a double. And then that'll be 4.0. So you do this, the first step, step 1, and then you do step 2 to cast that to a double. On the other hand, for the second one, it's different. The second one means we're going to cast I into a double first, which means what we will get in step number 1, we'll get 9 casted to a double, which will be 9.0. Right? And now we get 9.0 divided by 2, which is 4.5. Okay? So now, it shouldn't be too tricky for you to realize for option number 1, it's going to be just 4. And, 4.0. And this one is 4.5. If you are a first year student, I will give you certainly some exam question to test you on this. But you're second year, you're okay. Because I don't think that's important for this course. But since that's already mentioned in your lab exercises, I think it's worth mentioning. Okay? So don't worry about this in the exam. If I design the exam question, I wouldn't put this. It's, you have a compiler, you can just try. Go ahead. No, the division has higher precedence, I believe. You just try? Wow, then that will be counter to my intuition. Okay, guys, to be precise, why don't we try? I could be wrong. That's kind of from my memory. Why don't we try very quickly? Otherwise, I might say something just wrong. Maybe that's if I was wrong, maybe that's the other way I wanted to mention. As you can see, it's actually quite tricky. Sometimes you might just forget about the precedence. So that's why it's not really good to really test you on that. You're not a compiler. Okay? Okay, why don't we try very quickly? Just do a new project over here. I will just say test numbers. Okay, I'll make this code available to you after the class. So let's have a new class over here. Okay. If I was wrong, I'll change the notes accordingly, so don't worry. So now let's say test number, let's say just test double. And I want a main method here, so you can just click on the box over here, and you want a main method here. Okay. You know what? I think you could be well right. That kind of ring the bell to me. Okay. Is that readable? Okay. Okay, very good. Thank you. Okay, let's try this. So now, integer I is equal to 9. Integer j is equal to 2. Okay, that's the setup. So now, first of all, if I try system.out.println, and in this case, first of all, I'm going to do double and then I divided by j, first of all. Okay, just this one. And to make the error message more meaningful, I can just copy this whole string. So it will tell you exactly what it is trying to compute. Okay, and then plus. Okay, that's the first one. So let's see. What I said before, this one should really do the cast first. What I said before, you should do the division first, right? So what I thought. I divided by j first, and then cast, which means we're going to get 4.0. Okay, let's see if I'm wrong or right. I could be wrong. That's okay. It turns out I was wrong. Very good, very good. Okay, so I was wrong. Okay, so what's going to happen is, so now here's the rule. The rule is division has higher, you know what the precedence means, right? Because the multiplication has higher precedence than addition, okay? Has higher precedence than typecast. Meaning that we will do the other way. You see, I always got confused. Casting has higher precedence than, which means we will cast I to 9.0 first, and then we do 9.0 divided by 2, which means we get 4.5. So that's the correct behavior, okay? Now, I can add a little bit more to it, a little bit more. What if I don't want 4.5, I just want 4.0? I can use the pair of parentheses to force it, okay? I think maybe this is what I meant to write on the notes, okay? Let me write it down for you over here. Now, we use a parentheses to force the order of evaluation. Okay, what I'm going to do is, since I know by default, it's going to do the cast first, division next. Now I want to reverse that order. How do I do that? I can say, why don't you do I divided by j first, using parentheses. I will really emphasize that, so I will say something like that. Hopefully that's clear to you, right? I'm trying to do I divided by j, which is 4, and then cast 4 into 4.0. Okay? So that's kind of the stuff you can play around with the numbers. For example, you want to calculate the average in your lab. Okay? So now if I do that, I will get. So now let me also update this printout message here so we are consistent. And then I'll change the notes very quickly. Okay? In this case, we got 4.0. Okay? So if you really want to memorize something, you can memorize that division actually has lower precedence than cast. Okay, that's the take-home message. If you want to memorize that, I wouldn't memorize that. That's not really something that's worth memorizing. You got too many other things to memorize. Okay, let me just go back to the notes, and then I'll change that quickly. Otherwise, when you see the note, you'll be confused. Okay, what I want to do over here is, I want to say, I'm going to use eraser here. So this is not step 1 anymore. Okay, I'll simply erase this over here. So now I would say I divided by j. In this case, what it will do is it will do this one first, in which case it is going to cast that into 9.0. This is step 1. And then step number 2 will be do the division. And step number 2 is to do the division. This is step 2. 9.0 divided by 2, which is 4.5. So you really have 4.5. Okay? So you can see that now for option number 2, you can see option number 2 is the parenthesis that I added really necessary? It's not, right? Let me just make my point very explicit and we are done. You can see this pair of parentheses over here is not so necessary because we know that by default, typecasting has higher precedence than division, so it's there anyway. However, I would suggest when you're not so sure about, even though you're 100% sure, put parentheses. Like I was very sure, but I was wrong, right? So please put parentheses. Any question about this? So it's a very quick review. Yeah? Go ahead.
You know with the average, how we
Yeah.
0.0 plus
Uh-huh.
plus b?
Yeah.
Is there any way we could have done it through casting instead of 0.0 plus?
Yeah. Okay. So let me mention something. You see, I and j here, I might see what you mean. Okay, let me try to illustrate this very quickly. So since that's part of your lab. Yeah, so there are many ways to achieve that. So let's say this. In general, if you only have numbers, if you say 2 divided by 3, this will only give you 0, right? So to really get the precision that you want, you have to say add 0.0 to any one of them. For example, you can say 2.0 divided by 3. But now, if you got variables on both sides, if you got I divided by j, that will of course give you the quotients. Given that both are integer, let's say integer and integer. Now, of course, you cannot say I.0 divided by j. Conceptually, I know what you mean, but compiler wouldn't understand that, right? So now, here would be what you should do, cast. Okay, that's exactly what we talk about. So over here, you can simply just do this. So now, of course, this conceptually okay, but not for Java. So you can gotta say double cast I. Cast any one of them will be okay. Okay, this one will be fine, as we just learned the hard way. And this one also will be okay. However, if you say double I divided by j, no, that's not okay. So that one means you got to do the integer division first, which will give you the quotients, which is also integer, and then cast that to double, which will be just integer 0.0, right? Yeah. Does that answer your question, maybe?
Yes, sir.
Okay. Okay. Any questions before I move on? It's quite a detour, but I think it's worth mentioning any issues you might have, so that's okay. So I think for the labs, you do see some JUnit tests. It seems like many of you guys can still manage to do the labs, but I think since we only got one section today for JUnit test, we got also Tuesday section. So today, at least, I'll try to finish everything about utility classes. We still got several topics to cover. And then I will cover JUnit test on Tuesday, the latest point. I think the due date for your lab will be September 25th, which means you still got a lot of time after Tuesday. Okay, so I wouldn't worry too much about it. I really want to cover JUnit test properly, so I don't want to rush. Okay, so now let me just go back to utility classes that we left off. So we talked about the Circle utilities last time in very much detail. So if you still got any trouble, you can watch a recording or you can talk to me in person. So I'm going to assume you're reasonably familiar with the class, Circle Utilities. So the next step is about how we can use Circle Utilities in a way. Okay? So what I want to do, I want to go over some simple test using just console application like a main method, and we have several printout statements. I'll trace the program together with you because that will show you if I later on give you some similar questions. I might just give you some utility classes. I'll give you some sample code that uses it. And I want you to produce the output to me, right? So that can be one possible problem. And that's a really necessary training. Sometimes you don't want to rely too much on executing on computer. Executing in your mind also is something that's worth training. Okay, so now what I would do is I want to put, I do have that. So this is the program I'm going to trace. Don't worry, I'm going to write it down line by line. Oh, that's actually on my iPad. So this is the program I would like you to trace. I'll trace that with you together. Okay. You also got the Java code which you can play with. Before I do that, I want to mention one thing on the slides. So we have talked about how you can visualize a utility classes. Remember last time we talked about when you have a utility classes, everything is static. Attribute is static. Methods, they are also static, which means there's only one and only one single copy at the runtime. So now, given the CircleUtility classes we have defined, this is how you can visualize that. You can think of, this is a single big box over there. You can see that we have 3 attributes, radius to diameter, which has the value 2, radius, which has value 10, and pi, which has value 3. And then we also got the definition for all the static methods. So that's how you can visualize a utility class. There's a single place in the memory that stores all such information. And because radius to diameter was declared as final, and also pi was declared as final, you cannot change 2 to anything else. You can also not change 3 to anything else either. The only place you can change is the radius, because that was not declared as final. So that's the kind of the thing you gotta keep in mind when you try to trace the program. Okay? Having this in mind, I'm just going to trace this very quickly with you, and then we'll see how very quickly, and then we'll do it together. Okay? So now I'm gonna move on to my iPad. Okay, so now that's the program I'm gonna trace, but I will use another page over here. So remember, there's a definition for all the methods. So I'm going to write the program line by line, and then we'll figure out what the output should be. I thought that might be the best way. So first of all, I'm going to draw how the visualization should look like. So now you can imagine that at the runtime, there is going to be a single box for the CircleUtilities. I'll say CU, just for short. And remember, we got 3 attributes. So we have the radius to diameter, which has the value 2. We also have the pi, which is also constant, which has value 3. And we also get the radius value, which I want to just, is 3. Yeah, as you can see, it's 3 over here. The initial value is 3. Okay? You're absolutely right. Thank you. Thank you. Good. And now, dot, 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 which means we got all the definition for all the methods. You can imagine dot, dot, dot simply means the box on the left. Okay? So now let's run program line by line. The first line I would like to write is this. Okay, let me just refer to my notes over here. Okay. Okay, the first one I would like to do, okay, I'm simply going to say print. If I say print CU dot radius. First of all, you cannot simply just say radius because we are talking about a class that's outside the CircleUtilities. So you must use the class name, remember, right? So now what should be the output? 10, right? Current value is 10. No question about it. That's easy. Okay, let's move on. Second line. The second one I would like to do is I'm going to declare one integer. I'm going to say integer D1 is assigned CircleUtilities dot get diameter. I'll just say get diameter over here. Okay, so now let's see what's going to be the effect of this. You can think about every primitive value as a box, which will store value. So we just declare one box, which is called D1 over here, of type integer. And then we say cu.getDiameter. And we know that getDiameter is over here that we are trying to call. GetDiameter. Okay? So now we know that we're going to have diameter is going to be radius multiplied 2, right? Which will be 10 times 2. So we get 20. Okay? Like that. So far so good? Okay? So next line. So now what about if we say print line? If we say print line D1, that's easy. That would just be 20, right? Because the current value over here is 20, okay? So now the next one. What about if you say cu.circumference1? cu.get circumference1. Okay, I want to print it out, actually. Yeah. Let me just write it again. So I'm going to say print line. So I'm going to say cu.get circumference1. Okay, so now I know that it's going to call this method here, get circumference1. And in turn, it is going to call diameter, get diameter, multiplied by pi. Okay, so now get diameter is again this method here, which is going to be radius times radius, radius to diameter. So we know radius currently is 10. So 10 times 2 times 3, 60. Good, thank you. 60. Very good. Okay, everybody agree so far? Okay. You know, sometimes when you're doing live demo, you kind of become less intelligent. So you're now smarter than I am. So I'm tracing the program. You should really help me. Okay. Okay, now the next one. So now we're going to do cu.get diameter 20. So I'm going to say print line cu.get diameter, and then I'm going to pass 20 over here. First of all, you should realize one thing. This method call over here is different from this method call here, right? Because you're passing some argument value, 20, okay? So we know that it's going to call this method over here, right? Okay, so now let's be a little bit more careful here. Because I know the argument value is 20, so I'm going to have 20 over here. Right? So I'm going to have 20 over here. You can see that the 20 over here is the argument value. However, on the other hand, the radius right now at the CU level is actually just 10. So that's why shadowing does change the meaning, right? Okay, please, that's a very important point. So that means in the test, if somehow for get diameter, this method here, if I instead I say it's going to be CircleUtilitiesApp. In that case, you're going to use 10 rather than 20. Okay, that's my point. Okay, so now it's going to be 20 multiplied by 2, and then multiplied by 3. No, just 2. Okay, just 40, right? Okay, very. Thank you. Okay, you kind of get the idea. Okay, let's do maybe one more. Okay, so now what about we say get circumference 20. Print line. cu.get circumference, and then we say 20 over here. So now you can see that again, this method here is different from this method call here because we have, first of all, their names are different, right? So we're going to say get circumference 20 over here. Let me use red. So this will be the last one I will trace. I can leave the rest to you. A similar idea. So when you say get circumference 20 over here, so this will be the method we want to trace. So you get 20, right? And then you're trying to make this helper method call, which is over here. Okay, this one, we're going to use 20. Okay, let's go to that particular method, which is get diameter. And get diameter here, we're going to have 20 over here. And so that means we're going to have 20 multiplied by 2. And then also multiplied by 3, right? 20 multiplied by 2 multiplied by 3. That means we're going to get 120. Okay, so my point is shadowing does make a difference. So depending on how you define your parameter. Okay. Any question about this? Yes?
When you're writing out codes, it's better to avoid shadowing because it can be very confusing.
Yeah, so as you see, I would say it's a personal preference because shadowing, as you can see, for shadowing, the advantage, maybe the biggest advantage for people who like to use it is you don't have to come up with new name for your parameter, right? However, if you really know what you're doing, and you know that for Java, it's definitely going to do shadowing for you, feel free to use it. As long as you know what you're doing, then that's fine. But I would say if you're really not sure how shadowing works, or you more or less know how that works, you better choose a new name. Yeah. It's a little bit like for your constructor in Java, which we'll talk about. If you choose the parameter name for the constructor to be the same name as the attribute, you got to use this to disambiguate. Again, it's again a matter of style. I personally, I don't like to come up with new names, so I'll just say this.a is assigned to A, right? So it really depends on what you prefer. So there is no really good and bad. Yeah. Any questions before I move on? Okay, that's it about the utility classes. I think for your first lab test 1, I'll give you guidance maybe about a week before the lab test. But you can imagine that for the utility classes, it will be somehow like a combination of what I show you in the class and also the kind of method that you have to write for lab number 1. That's kind of the cases. Or maybe I'll give you some tracing problem, okay? Maybe to just, as long as you know how to use the utility classes, how you can write some simple methods, you should be fine, okay? And also maybe there might be some JUnit question too, which I will talk about. Okay, so now let's go back to the slides. I want to talk about something that's also very interesting, how we can document the utility classes. So when I say documents, I'm not really referring to Javadoc. We are going to talk about Javadoc. I want to talk about something that's more important, okay? So we talk about visibility, we talk about how you can use utility classes. So now I want to refer to how you can use utility classes. So now for those, every one of you, since you're in CS, you will be taking 3311 software design at some point. So I'm currently teaching that, so I realize it's quite a nice connection between 2030 and 3311. Because over here, we need to talk about a little bit about precondition. So I want to give you a better introduction about a little bit about software engineering, a little bit, so you have some idea. Okay? Let me just go over some slides just to introduce some terminology to you. And then I will show you how this is relevant to what we're doing here. Okay? It's not that complicated, just some terms. Okay, let me just use my remote control here. Okay. Does it work? Oh. Okay. So now we talk about client versus supplier. Let's not worry about Java just yet. Let's just talk about a little bit more general terms. What does it really mean to be a supplier? Supplier means somebody who is going to give something, is going to provide a service. They implement something. In your Java term, that means you're implementing some utility classes. Then you are the supplier. You're providing, for example, the math class, or you're providing the average method for somebody else to use. You are the supplier. And then we talk about clients. Client is simply somebody who is going to use the service that's implemented by somebody else, right? So somebody is going to use a service, which is called client. So now, there's something that's really important to notice. Let's use a simple example, microwave. So let's say we got microwave supplier. Let's say I'm the microwave supplier. You are the microwave user. So you are the clients, I am the supplier. So now we talk about there's got to be some contract between us to constrain the behavior for both of us. Let me try to explain that to you before I present the slides. So now, for me as a supplier, I cannot produce just a magic microwave. For example, for you as a user to use my microwave, I will have at least 3 assumptions. I will assume that when you actually use a microwave, you better power that on. And also, you better close the door of the microwave when you use it. And also, you wouldn't put something that's explosive into the microwave. So these are the 3 assumptions that, wow, I hope I hope the mic doesn't capture that. I'll fade it off if that's capture. Okay, anyway, so me as a supplier, I make certain assumptions about how you as a user or as a client is going to use my service, okay? It's power on, the door is closed, and also there's no explosive to be heated on in the microwave. On the other hand, let's say you as a user, as a client, if you actually really satisfy the instructions I gave to you, what can you expect? You can expect if you put your lunchbox into the microwave, it's going to heat it up properly, right? So we really have some kind of contract between us. I expect something from you, so you got obligations. On the other hand, once you fulfill your obligation, you expect something from me, so you got some benefits from me, right? So we talk about obligation, we talk about benefits. So we really got some contract over here. That's really what happens in real life. But in object-oriented programming, this one is quite straightforward to really think about. I'll give you more code example in just a moment. Okay, so this is the part you can, so that's exactly what I said. And one thing that's also important, you as a client, you only care if the service that is provided by me has been given. You don't really care how I implement the service. For example, if I say, now please implement the average method for me. For me, as far as I'm concerned, now I'm the client. I only want the 3 numbers to be calculated for their average. I don't care how you do it. As long as you can give me the answer, you either do cast or you don't do cast. As long as the answer is correct, I'm okay. Okay? So that's kind of the relationship. Okay? So now benefits, obligation. So this table here, feel free to really make sense out of it. Otherwise, you have to make sense out of it in 3311. You'll see the same table again, I promise you. Okay? So now, here we simply say, for the clients, you have to follow the instruction. That's your obligation. But once you have done that, you will get a service from the supplier. So that's the benefits you get. You can see that interestingly, this table here is symmetric. So what happens to be the obligation for the client, which is to follow instructions, they are at the same time the benefits for the supplier, right? They are symmetric, right? Okay, how does this apply to us? Bear with me, we're getting there. So one more turn is about contracts. So in 3311, later on you will learn about a software engineering principle called design by contract, which means when you are trying to do a design for your software system, you have to think about what's really the relationship between different parties, different client, different supplier, and the way to really have a very good design is to have contracts. And in this course, we only teach you one kind of contract, which is called preconditions. That's the only one, which means if I'm the microwave implementer, I will have to give you some precondition to say you must power on, you must close the door, and also you must not put anything that's explosive, right? We only teach you preconditions in this course, okay? But I want to talk about design by contract in a bigger picture. Okay, so now, let's see one example. This is a critical point. Let's say we have, let's not worry about microwave anymore, okay? Let's move on to something we are more familiar with. Let's say I have a simplified version of the CircleUtility, I should call it CUtil. I have a static integer called pi. Not worry about if that's constant or not. We have a pi. And also, I have one method. You can think about every method here is like a surface that can be used by somebody else. Well, I'll show you just on the right-hand side in a moment. So this surface over here, we're trying to do r times pi, which is 3. That's going to calculate area. You can see over here, there is an implicit assumption over here. I put it in comments. As you know, comments in Java do not have any effects. It's only for you as a programmer to read. The computer is not going to take that into account. I say that I assume the R that whoever my client is going to give to me is going to be positive. Why? Because it doesn't make sense to have a negative radius circle. It doesn't exist in reality. Right? So that assumption there is only a comment. Okay? Let's see. But I'm going to demonstrate to you this kind of design is actually has flaw. Why? Let's see how so this is the supplier. This CircleUtility is the supplier. How would the client look like? Let's have some very simple application for the CircleUtilities. So I highlight this because now in the context of this class, we're going to use the service from CircleUtilities. So let's say I'm going to assign the radius to be some value. The reason that I put a box over here with question mark, that means it's completely up to the clients, up to them what kind of value they can assign. They can assign -10, they can assign 10, any value, as long as they're integers. Now, if I do, and then I will do print line, CircleUtilitiesApp radius, okay? So here, let's first talk about the client-supply relation, okay? Let me just do that very quickly, just on the paper, and then we'll move on to some code execution very soon. Okay, and then I'll swap to my iPad. Okay. Do you see that? That's, okay, how about this? Okay, guys, bear with me. That should be fixed within 1 minute. Don't worry, recording is still recording, but I just need to launch the recording for iPad again. New movie recording. Okay, there we go. We're back. Okay, very good. Okay, thank you for your patience. Okay, so now let's talk about client supplier. Okay, so now first of all, we have something called CircleUtilitiesApp application. Let me just simplify that code a little bit just to explain to you the concept. This is the class. And then we know somewhere inside this class, in the context of that, we are trying to make a method call. First of all, we declare a variable. We didn't declare. Just CircleUtil dot get area, and then we pass some radius. Okay, and then there's something there, okay? So now, let's now focus on this method call in the context of this class, okay? So now, let's say this. Now, we are trying to use a surface from this class over here, and the surface name is called getArea over here, okay? So I would say this is the surface name. And this class over here is the supplier. Okay, so far so good. We are using a service from this particular supplier. And since we are trying to make this service call within this method over here, so that class should be called the clients. So I mean this one here. So this is the clients. So clients is using a service from the supplier. Okay, let's make it clear. Okay, so now, question for you. Let's say if I try to pass a value over here, me as a client, let's say pretend I'm the clients. If I pass -10, what's going to happen? What will be the result that's going to be returned? I'll let you cheat. If I pass -10. 300, right? Because you can see that according to the definition for the supplier, the assume over there has no effects to prevent any negative value from being blocked. So now -10 multiplied by 3 will give you 300, which means somehow the supplier does not complain that -10 does not represent an existing circle. Right? There's something wrong here, something wrong. That's what I can tell you. Okay? Let me just go back there, and then I'll tell you how to fix it. That's why we're going to talk about preconditions. Okay? So now if we do that, and over here, supplier will simply just calculate. Well, just calculate -10 squared times 3, which is 300. This is absolutely not good. Okay, I'll say why it is not good. So this is not good. Should be an error. Which means at some point in the supplier's code, they should check if the input they are being requested to do the service are really legitimate or they're reasonable. Okay, that's my point. Okay, let's go back. As long as you understand client supplier, so this slide I think is pretty much done. Okay, exactly, so 300. You can see 300 would be also the area for a legitimate circle if that's 10, right? So you shouldn't give the same result for, yeah, the same. What's wrong with this? So there shouldn't be an error, okay? Let's talk about this idea over here. So we'll only introduce you only one kind of contract in this course. We'll teach you more in 3311 later, okay? Let's focus on precondition. Precondition is very easy. So basically, under what circumstances can the supplier assume they're going to implement their service? For example, there is some small example for you to practice over here. Let's say, I should have made some animation. You see the answer already. Okay, let's see for division. Let's say you are the supplier for division. You ask me to give you X and Y. If you didn't say to me what X and Y should be, I might just give you 5 divided by 0. In which case, you cannot give me any meaningful result. There's no way, right? So you should have told me that the precondition for me to use your service of division is that the divisor Y over there cannot be 0. So that's a precondition. If there's any precondition violation, which means if I give you 0 for Y, there should be some exception thrown. Okay, that's kind of the idea for precondition. Okay, I got another one. Okay, how about this one? Let's go back there. How can we fix the get area? We'll simply say the R should be not positive, right? Yeah, just positive, let's say. Yeah. Well, it's really up to you. Do you really want to have a circle with radius 0? I think mathematically it can exist, right? Yeah, like a radius 0. Well, you wouldn't have any, like a trouble with calc multiplication, but negative is certainly illegal. Okay, let's just say positive for now. Okay, now, if the precondition is not satisfied, then we have to give some exception. So for this course over here, we're going to simply make it easy for you. So we're going to practice this in just a moment. So you as a supplier, you're going to think about what precondition it should be. If the input value does not satisfy the precondition, you have to throw some illegal argument exception. Remember I said the difference between parameter and arguments? Argument means when the client gives you some specific value for calculation, that there are the arguments. If those value happens to be illegal, you're going to throw illegal argument exception. Okay. So let's see example in just a moment. We are getting there. So now let's go back. So you got to say if the input value is invalid, then I will throw illegal argument exception. Otherwise, like else, I will just do the normal updates or normal calculation. Let's see this. Very simple. So let's say we still have our circle utility class. Let's say within get area over here. So now we say that it throws illegal argument exception. It might throw that. And then we'll say that if R is less than 0, if the radius happens to be less than 0, then we're going to throw new illegal argument exception. Are you comfortable with the expression there to say throw new illegal argument exception? I suppose you did something like that in the first year, right? If you really got trouble, so I see somebody nod their head. Are you okay with that? Okay. If you really got trouble, please get in touch. I'm happy to go over with you the exceptions. Okay. Otherwise, if the precondition is satisfied, which means the radius is not negative, so you can actually calculate the area. So that's the new precondition we introduced. Again, so I kind of started with the big idea about design by contract, very big context. You got clients, you got supplier. And in this course, we teach you a specific kind of contract, which is called precondition. Whenever you're trying to implement a method, you got input parameters. You got to think about what should be the normal circumstances for me to operate, for me to compute according to those values. If there's no error, of course. If there's no special circumstances, of course, there's no precondition. But if there is, like a division by 0, then you have to give some precondition error. Okay. Okay, let's move on. Any question about this before I move on? That's a precondition. Okay. Are we okay, or you need more example, or? If it's a throw new, illegal argument exception. Yeah, you can also see in the slides. Okay. Okay, so that's about how you can define just one kind of contract for your code, which is precondition. Okay. So now let's go back to also how you can document everything in your class. So there is a simple utility for you to use, which is called Javadoc. So I'm gonna do that on the computer with you. It's very easy. Okay, let's do that very quickly. Let me, first of all, let me just go through one slide, and then we can do it together quickly. And then I can move on to JUnits, just for a few slides. Okay, first of all, so there are 3 kinds of comments in Java. I'm sure you have seen the first 2. If you just want to have one line of comments, you get double slash. If you want to have maybe like a block comments, you can have maybe slash star and star slash, right? That's how you do the longer comments. Now, be careful. If somehow you have, let's say, 2 stars after the forward slash, so that means you're trying to document your code for any potential user or potential clients of your code. Okay? Again, I will illustrate to you in just a moment. If you write these first 2 kinds of comments over here, they will not be seen by any of the user of your program. On the other hand, if you try to use this type of comment over here with 2 star, the green one, over there, you can somehow generate some HTML page to see the documentation. Okay? So I'm going to illustrate. Don't panic. Okay. So you do have one example over here, but I'm going to just do some live demo with you together. So just you got some more impression about it. And then I will just tell you some exercise that I would like you to do over the weekend. I'll go over the solution with you next week, but I would like you to try. So that's a good practice. Okay? Let's now launch Eclipse. I want to do some Javadoc with you. Okay? For you to get some idea. So Javadoc, in some ways, really documentation for yourself and for your clients. Okay? So if you go to Package Explorer over here, let's now go to File, New, and then Java Projects. Okay? So I'm going to say, let's say Javadoc example. So that's a new project. Okay? Okay, let me just close this. Okay, let me close this class over here. Okay, so now let's just create one class. Okay, presumably you can also create packages, but the idea is the same. Okay, let's just create a class. Let me just call that maybe foo. There's a class over here. Okay, just like that. So now I'm trying to develop this class. So the best practice for software engineering is you do your documentation not in the last minutes, not just for making your boss happy, right? So you do the documentation as when you are developing your code. Okay, let's try to do that. Okay, so now I can just make this just a slightly bigger for you. Colors and font, and then I can go under Java editor. How about 18? That could be too big, actually. Okay, not too bad. Okay, so now, as I said before, if you say /2 star and then hit enter, so that means I'm trying to document the class, right? Because now I'm trying, okay. So, and basically everything can be written in terms of HTML. So what you learn from 1011 can be applicable if you want to. But we don't really teach you anything fancy here, okay? So let me just say this is a new paragraph. First paragraph of class foo. And then I can just make another paragraph. Second paragraph of class foo. So somehow all these that's included within the 2 star block will be generated as part of the HTML. We'll see that in just a moment. Okay, so you got, so and also, of course, you can put your name as the author. Okay, so now that's about the class. You can put as much description as you like. So, but for this, it's only for illustration. So now, let's say we're going to have a utility class, since that's what we have learned so far. I'm going to have some attributes. I'm going to have some mutator and also some accessor. Okay, let's see all three of them. And also, let's say one of them might have a precondition violation, which we just learned. Okay, let's do that quickly. So now, first of all, let's see, do the simple one. If I say public static int I, the initial value is simply just 10. So now I want to document these attributes. Of course, the documentation depends on you, what classes you're defining. But since it's a documentation, so I'm going to have 2 star over here. I'll say this is a static attributes with initial value 10. Okay, just documentation. Okay, that's about document. It can be as long as you like. You can also put paragraph if you like. After that, you also have, let's say we have a accessor first. Let's say a mutator. Mutator first. Mutator is slightly easier. Public static, and then we have void mutator n. And then we have some implementation. Implementation. So something I want you to pay attention to. You can see the color in Eclipse. You can see the one that start with the 2 star, they're blue. And this one is actually green. The green ones kind of tell you that there are different kinds of comments. So the comments within the method will not be seen by anybody else outside this class, only the blue one. Okay? That's why I said there are 3 kinds of comments. Okay? So let's not worry about how we do the body of the implementation. Let's see how we can document this. Let's give some parameter to it. Integer I. Let's say Boolean B. Okay, and then I want to start with the documentation over here. First of all, this is a mutator method. Okay, you can, and then now for the mutator method, if you have if you have 1 or more parameters, you better document every parameter. Okay, since in this case we got only 1. So you're going to use a new tag. You're going to say add paren. By the way, if you do in Eclipse, you can see that as soon as you type the add sign, it will tell you that the options you have. There are many tags over there. You can certainly explore, but for the purpose of this course, we only teach you the most important ones. Okay, you can say paren. Paren simply means parameter. After the paren, you have to say exactly the same name. Oh, I got some duplication. Sorry about that. After paren is B, it has to be the same name as a B here. Has to be the same. Otherwise, there will be some errors when you generate the Javadoc. After this, you will simply say some description. Description of B. Parameter B. Okay, so once again, one more thing I want to mention. So there, for every method there, whether there's an accessor or mutator, so there is a distinction between method summary and method details. Okay, so I will tell you what that means. It's very easy to understand. So first of all, let's use the paragraph tag from HTML. Let me just make it even more explicit for you. This is a mutator summary. And then a second paragraph. I'm going to say, this is more details. There are more details, let's say. More details about mutator method M. So now I can just tell you what's going to happen. Later on, you will see in the documentation, the method summary is only going to include the first paragraph. All the rest will be included in the details. Okay, that's quite straightforward. You're supposed to have one summary line and then more details for every method. Okay, that's about the mutator. Okay, let's do accessor very quickly. Let's say for this particular accessor, we might also have maybe some precondition. some exceptions. Again, let's say public, static, let's say integer, and then accessor, let's say integer I, integer j. For example, you can have as many parameters as you like, including just even 0 parameter. In this case, let's say we simply return, I'll say return -1 for now. That doesn't matter. Now let's document this method here. Okay, I'll make it a little bit higher for you. Okay, so now / and 2* over here. You can see somehow Eclipse is very clever. It generates the minimum number of tags for you because they know that you got 2 parameters, I and j, pretty good. And also it's an accessor, so it knows it returns some value. Okay, let's document that. After I, you gotta have at least 1 space. Let's say parameter I, parameter j. Of course, these are just generic description. You gotta modify that for your specific example. So what do we return? Let's say return, let's say always -1. Doesn't matter. Okay. So now I want to say something else. Let's say the method is going to, let's say, throw some exception. So the tag I would like to introduce is called exception. Exception, you gotta say what kind of exception might occur. Illegal. If you just do control space, it's going to give you some option. Illegal, and then arguments, exception. Okay, that's how we encode the precondition. Okay, and then I would say you will throw this when, let's say I plus j is less than 0. Let's say, for example. Okay, let me modify this just a little bit, okay, to make more sense. If I plus j is less than 0, then we're going to throw new illegal argument exception here. Otherwise, we're going to return as normal. Return -1. Well, doesn't make sense. How about 10? Return 10 if I plus j is greater than or equal to 0, right? One thing to mention, I'm pretty sure you know, but let me just emphasize that. The else part, we know that the condition for the if branch is I plus j less than 0. We know that the condition for else should be the logical negation of that, right? Which would be I plus j larger than or equal to 0. Okay, good. Any question about this? So we have so far done the documentation at the class level and also for every attributes, every methods. And for mutator methods, you don't have to say at return. There's no return type for mutator. But for accessor, you must have return at return. Okay? Okay, now how do we generate Javadoc? Extremely easy. Go to projects and go to generate Javadoc. As easy as that. Okay, so you got to select the project we'd like to generate the Javadoc. Let's say Javadoc example, the one we did. And then you can choose where to generate the HTML into. By default, it's going to just go to your project folder and then create a subdirectory called doc. And you can say finish. So let's say yes to all. Okay. There might be some error there. But let me just have a quick look. If something goes wrong. Okay, let's try again. I'm not sure what the error is, but and finish. Okay, but you can play with that. Okay, so now let's say how do we see the documentation? So the way to see it, you can see now in Package Explorer under doc. There is a file. You can see lots of HTML being generated. Only look into the index. If you click on index, it's going to open up something that should look kind of familiar to you, right? For example, when you use a math library, they got something exactly like that. Okay? So now you can see that whatever we put before, you can see we got description for class foo, and also you can see first paragraph, second paragraph, And also one thing to notice, you can see for method summary over here, you can say this is a mutated method summary. That's the first paragraph we put. Later on, you can click on end. There's a hyperlink for that. Click on end, you can see it tells you all the details. Okay? You can just kind of see all the documentation text we put there has been included in the HTML. One more thing. Remember I said before, whatever you put using the normal comments block like this. For example, here, implementation details. You will see that implementation details is this kind of comment is only for the supplier. So if you go to this documentation here, which is going to be made public, so nobody should see that implementation detail. So if I simply just do some search through, you wouldn't see the implementation details over here in the HTML. So that's my point. So you can feel free to still document the internal workings of your implementation, but just make sure you use the right kind of comments. Okay? That's about Javadoc. Any questions? I know it's a little bit quick, but that's something you can also very easily learn. But I thought the best way for you to learn is to just go over some simple example with you. Okay, so now exercise, before I go to JUnit quickly. We still got some time, okay? Okay, so now here is the exercise I would like you to try. I will just go over very quickly. I want you to create a utility class called counter, okay? So we're gonna have different counter methods I want you to implement, but they're fairly easy. But I want you to practice everything we have done so far. I want you to practice how to encode preconditions as exceptions. I want you to practice how to use Javadoc to document your classes, right? So those are the things I might want you to do in the lab test. Okay, so here are all the requirements you're gonna follow. I wouldn't read it through, okay? So everything about the assignments is on the slides. There's no submission required, but I will encourage you to try. Don't wait for me to go over the answer with you on Tuesday, okay? Any question about the what we got so far? Yes?
How do we check, let's say we want it to be strictly int, but then somebody enters decimal number. How do we check?
The question is, let's say if your method parameter is integer. Okay, let me just talk about this example very quickly, okay? And then I want to move on just to JUnit quickly, okay? Let me just go to my iPad. Let me just close Eclipse. I don't need that anymore. Oh, let's keep that. I might need that. Minimize that. Okay. Now I'm back in my iPad. Good. Now let me add a new page over here. Okay, the question was, let's say I'm the supplier, and I'm trying to define a method like this. Let's say class my utilities. And then I have some method. I would say static void, let's say m. Over here, I'm taking integer over here, right? Let's say x. Okay, it's going to do something over here. So the question was, over here, how can I encode a precondition which is going to require when people pass some double number to me, I'm going to throw some illegal argument exception? That's the question. Okay, is the question clear? Okay, so what's your response? Yes, exactly. That's exactly the point. The compiler will catch that. Okay, I'll show you guys why. It turns out it's much easier. So anything that has something to do with types, the compiler will do for you. Okay, I'll show you why. It's actually much easier than you thought. Let's say over here, if I have class my utility application over here, okay? So now if I try to make such a method call, if I say my utilities dot n, as you said, if I put 23.4, how can a supplier check that 23.4 violates the precondition that it should be integer? The response is you don't have to, because the client code over here will not even compile. You will see red underline. in Eclipse, because it's going to tell you we are expecting integer, but you're passing a double. Okay? You don't need to check explicitly. Okay? So that's a compile error. Now, how would you fix that? Of course, you as a client got to fix that. Either you can either cast that to an integer, or you can do whatever you like, right? So for example, one way to fix it is you can say, I want to cast this to integer. If I do this, it's going to truncate all the fractional part. That's one way to do it. Okay, I will just spend about 5 or 7 minutes just on JUnit test. Okay. There's one thing I would like to mention. I reorganized our course webpage slightly. Hopefully that makes you a little bit easier. So if you go to our section page over here, so now you cannot find slides over there anymore. But don't worry, they are still there somewhere else. So if you just go to the lecture materials over here, so you'll see that I kind of put a slide in the same place. So just easier. This is a single place that you got to go for the information. So now, so we are already done with all the utility classes. I'm going to make it complete. So you can print it out if you like. But now, I'm going to start the JUnit lecture from maybe only the first 5 minutes. And then I will continue from Tuesday, hopefully finish that. But feel free to really read over the slides over the weekend. I think the slides are pretty much self-contained. But I would like to go over some concept with you as well. But feel free to pre-study. Okay? Let me just spend about 5 minutes, and then we are done on JUnit test. I would like to talk about JUnit test from a perspective that's kind of not so much relying on Java, because JUnit is simply a framework for doing unit testing and regression testing. I think from this lecture over here, it is more critical for you to learn about what really unit testing is and what really regression testing is, because if you really don't program in Java when you go for a software engineer job, you may have to do your programming language in C++ or in C# or IFO. You heard about it already, right? For 3311, any language. In that case, they might have their own unit testing or regression testing framework, but idea is really the same. Okay? But of course, for illustration, I'm going to use JUnits. Okay. So now, let's see what's the big picture. Let's just go over some slides to know what the problem is, and then we'll continue on Tuesday. Again, let's find a very simple example. You might find some inspiration about completing the exercises I assigned to you from this example here. Okay, let's try to do that. Let's say we have a very simple counter class. Let's say I have everything is static. I have 2 constants. One is the maximum counter value, which means the counter value can never exceed 3. It can be up to 3. And also I got a constant called minimum counter value, which means the lowest you can get into will be 0. You can never go below. So which means it can be a 0, 1, or 2, or 3. Okay, so these are only the 4 possibilities. And then I have a variable called value, which has the initial value, minimum counter value. Start with 0, you can go anywhere between 0, 1, 2, 3, or 3 to 1, like that. So now, of course, just to remind you, if you want to access the value over here, you have to say counter that value, right? Because it's static. And then, now, there's only one requirement for finishing this class. I'm going to show you 2 methods there. First, the only requirement is the counter value must be between the minimum and the maximum. You should never go above or below. Let's now just have some intuition. Let's say I want you to implement a method called increments. And the increment is going to increment the counter value by 1. Will there be any precondition for this method here? Or never be?
As long as value is less than 3 or equal to 3 and greater than 0.
Would that be okay? Okay, that's very good. It's definitely on the right track. But let's be a little bit more precise. Okay. So now let me switch to iPad. And let me close that. Okay. So now let's say this. Let's just think about something more conceptually. Okay. We still got a few more minutes. Okay. So now, first of all, let's think about for counter. We know that the value must always be between 0 and 3. So that's our requirements. Okay. Now, I want to increment a mutative method called increments. Let's think, first of all, the implementation is very easy. It's going to be simply the value of the counter is going to be plus plus, incremented by 1. Okay, so now, can I just call this method at any time? No. Okay, can you say that again, Raymond?
As long as the value is in between 0 and 3.
As long as, yes, as long as it is in between, then oh, really? What about the value 3?
It's okay.
If the value happens to be 3, 3 plus 1 will give you 4, right? Very good. So basically, let's think about different precondition. Okay? Not only that I want to show you what the right precondition is, but we better learn some wrong ones so we can really learn. Okay? Let me write maybe your initial attempt and explain why it is not so appropriate. First of all, if you say the precondition, let me just draw some English here, but you'll see the point. If I say the precondition is that okay, let's say, let me put a question here. When should we throw a illegal arguments exception? So when should we do that, right? So let's try one example here. Option number 1. If I simply say, if the value is larger than the maximum, 3, then I will throw the exception. Let's think about if this precondition is good enough. Okay, I'm saying that I'm going to have some if then else. I'm going to say if the current value of the counter is larger than 3, then I will throw the illegal argument exception. But when I ask you if the precondition is appropriate or not, does it have any missing cases? Which means, can there be still any problematic scenario? I heard something? When it is equal to maximum, right? Is that what you said? Maybe that's what I want you to say, I guess. Okay, just to save time. Okay, I think she said this. She said, we have a missing case over here, so this is inappropriate. Very good. Because if the current value happens to be the maximum, 3. If current value is actually equal to maximum, so you can see the value happens to be 3, and the maximum is also 3. 3 larger than 3 is false, which means we will not throw that exception. However, if you try to increment when value is 3, you will go above the maximum. You'll go to 4, right? So that's problematic. Okay? Everybody got the idea? Okay? So I will just stop here. Think about this discussion here. I'll review that again. I'll see you next week.